So I thought I'd do another update because it's been quite a while since the last one. So hopefully now everyone's received their Synio stove jet, apart from a couple that I posted out, which I'll do today. So we've had some really good feedback, but we've also had a little bit of negative feedback. So I'm going to address this and just see what the expectation should be on different types of stoves. So before we get into the feedback, we've got our first upgrade. So this tiny little screw has been the pain of my life. It was just rounded off, and I've lost a couple of stove jets until the spares come to actually being able to fix it. So what I'm going to do is just show what needs to be happen. I've ordered more fixings from suppliers, so we should get them, and I will send out. The tricky bit is that we need this like little PH0 screwdriver. In future we'll just need a set of Allen keys and our torque driver, which should be like a spoke one, like this one. But again, that's a sort of future project. So take the fixings out from the bottom. I can kind of talk for the design a little bit as well, because these like fixings have been quite difficult because it's quite a hard thing to machine. Is this base, these base here, so I've had to do a little bit of rework on that. So here we go. And then we take the propeller off. Comes off just with an Allen key. And then what we've got is these little fixings in here, which are M2.6 Phillips screws, but what I've done is I've changed these to M2.5 because the manufacturer said it's okay, which is like a hex, which is much better fixing stainless steel. So undo this, that's one out, put the new one in. So the very smallest hex fixing, tip it on its top. So all the new pre-orders, they will come with these new fixings, and the people that have already ordered them, then I'm just working out what the best way is for you to get these fixings to be able to change out yourself. So that's the second one, the fiddly little things. There we go, and then just tighten it up. So much better, it's like just fits. And then we pop the propeller back on. Make sure you line it up with the, it's got a flat on it, so when you put it on, make sure you line it up with the flat, the grub screw. So I'm going to discuss the propeller a little bit more in detail as well later on in the video. So that's back on there. You get your unit, and then when you drop it in from the top, like that. I like to put it on a bit of like a dust sheet as well, just a kind of dust cloth, just to keep it from getting scratched. You drop in your fixing from the top. Second one, to get alignment. Keep it nice. Sign it up. Get it nice and tight. And then you can tell that it's all fixed, and then there we go, I've updated the fixings. So when I was building these stove jets, I did notice I caught one, which was, what it was is the propeller should spin clockwise. That's the way it's wired, and that's the way it moves the airflow. For whatever reason, it was spinning anti-clockwise. So when you start up your stove jet on your fire, just double check that when it starts up, it should always start clockwise. So the propeller itself is kind of a pressed piece of aluminium, and it's like more of an art than it is a science, because it depends on how much pressure is put into the mold, the position of it. There's quite a lot of factors in actually getting this right, and then there's like a pressed piece of aluminium, which is the shaft, which then goes onto the back. And if this is like slightly out of alignment, or it presses slightly different, this can cause a bit of an headache in terms of the balance. So if you take your stove jet apart, you'll be able to sort of have a look at the balance of the propeller itself. So what we want is like a kind of nice gap between each propeller blade and the motor shaft. So when you spin it and put it on, you can kind of see that, you know, the balance is quite good on that one. It's still a little bit of movement, but this is what I think we're going to refine in future. We're going to look at different types of propeller, especially for like a hotter stove, because what it's doing is the noise is coming from, because it's rotating very fast, and the propeller itself needs to be well balanced, and also, I get the words for it, it's kind of, the pitch as well needs to be like perfect in terms of the airflow. So that's something to look out for. Just so have a look at your propeller and just see how well it's balanced. You can bend the blades a little bit to kind of align it, so you can kind of just tweak it. And I think that's what people do on other sort of stove fans. So I think that's how it kind of covers the propeller. So we've had some incredible feedback, and I'm honestly really pleased. It's been really good to sort of hear your comments and see your videos. But we've also had a little bit of negative feedback, so I kind of think it's worth addressing this. I think what happened is Mick showed a video of the paper moving, and everyone thinks that their stove jet should do that. But what it is that Mick's probably got a traditional type stove where it's kind of connected to the unibody, but more modern stoves are like a cylinder. But it's still effective, because you can see kind of, I'll show the customer videos at the end of this, but Ian's stove is like a cylinder type, and it's still moving a decent amount of airflow. So we will work at like 100 degrees. So let me just put this on here and get this going. Again, it should spin clockwise, hopefully. Give it a couple of seconds. Just take the energy, there we go. So while it gets up to speed, so the best thing to do really is if you get one of these thermometers and you put these onto the top of your log burner, it'll kind of give you an indication of what you should expect from the stove jet. So the sweet spot of this product is around like 150 to 200. You get above 200 and there's like a performance curve, and it starts flatlining. We're capable to go up to 300 degrees, but when you get above 250, the airflow moves incrementally. So yeah, we're nearly there now. So when we've had one customer as well that said it gets too noisy. So again, this could be down to like the balance of the propeller. So it might be worth you looking at that. But also I think what it is that when we're moving at 200, 250 degrees, we're spinning very fast. So I think for higher end stoves that create more heat, we need to probably look at this propeller and optimize it. Maybe we add more blades to it. We increase the weight of the material. It's like a whole new R&D exercise. So it's something that I don't want to get into at the minute. So yeah, I think we should be spinning now. This is spinning at 100 degrees, and just kind of give you an idea of the airflow. So if I put the tissue in front like that, you can see it's clearly blowing up the tissue. You're not going to move paper at 100 degrees like mixed stuff. So I get to there, you can see we are moving tissue.